Hello everyone, how's it going? My name is Dan the Tutor. Today we're going to be finishing up our discussion on conic sections. This is the moment you've all been waiting for. It's the final case, the parabola. But there is one thing about the parabola that this is not the parabola that your mom made growing up and served you at dinner. This one's a little bit trickier, and let me show you why. So first, you know that a parabola from like Algebra 1 or even Algebra 2 is something that looks like this. Y equals x minus 3 squared plus 7. You know what a parabola generally looks like, but we're not necessarily talking about these kinds of parabolas when we talk about conic sections. We want to get this in the following formula. We want to get it in the formula 4p times y minus k equals x minus h squared. Yeah, not what you were thinking, was it? Now, first of all, I do want to say the center of this parabola will be at h comma k. And you may be wondering, what is p? Well, p is the distance to the directrix. And then that begs the question, what's the directrix? Slow down with all your questions. We're getting them. So the first thing I want to do is I want to take this problem I had right here and change it to the form I want it to be. So in other words, I'm going to subtract 7 from both sides because I just want the squared part by itself. So it's going to be y minus 7 equals x minus 3, quantity squared. Actually, I just realized we don't call it the center for a parabola. We call it the vertex. Silly me. So that's the vertex. Anyways, the vertex here is going to be at the point 3, 7. I also know that this parabola is going to open up, and that's because the squared term is positive and it's x. So in other words, this opens up. And that's because, again, we have an x term squared and it's positive. If that was negative something squared, then it would open down. And if there was a y there, that's when it starts opening right and left, which we will look at later. So we know the vertex is this. Now the directrix. So you'll notice here that if I put this in parentheses, then you'll see that if I want to set this equal to 4 times p, and I put a 4p here, and I want to solve for p, because this is the form that I want it to be in. If you don't understand what I'm saying I need the 4p to be here. And now we're going to solve for p to find out exactly what p is. Remember that before, there was nothing here, meaning it was a 1. What I'm trying to say is 4p is equal to 1. And if I divide both sides by 4, then that means p equals 1/4, which means that is the distance to the directrix. So let me just draw this parabola right now, and then maybe you can start to see what I'm talking about. I know the vertex was at 3, 7. Let's just say it's at 0, 0, because I just want to make this as easy as possible. So here's the vertex at 0, 0 for my new parabola. And I know a parabola that opens up is going to generally look like this. Now, if I have a directrix at 1/4, what's a directrix? It's a dotted line on the other side of the parabola. So I'm saying this distance right here, from my point to my blue line, that distance is 1/4. Very small. It is also the distance to the focus of my parabola. So this distance right here, that's the focus. And the focus of the parabola is also going to be a distance p away. So that means a distance of 1/4 away from my vertex. Now, what's so special about the focus and the dotted line, which again is called the directrix, and why have we never heard of this before in math? That's because there's only one time we ever talk about the focus and directrix of a parabola, and that's conic sections, which is what we're doing right now. So basically what this means is, and I'm going to erase some of my lines to make it cleaner, because I want to make a pretty cool point here. I don't know if cool is the right word, but it'll be a point. Basically what's special about the directrix is it's the exact same distance to the focus of my parabola. So let's pick a random point. I will choose right here. What I'm saying is the distance from my focus, this green line here, is equal to the distance to the directrix, this other green line right here. If they don't look exactly equal, it's because I'm not a great drawer. I apologize for that. Now let me pick another point. Let's pick this point up here. What I'm saying is the distance to the focus, that distance right there, is the exact same as the distance to the directrix, which is just a straight line down. And again, this isn't perfect, but what it's supposed to look like at least. And so that's why we have the directrix and the focus for this parabola. Now, what do we need to know for the parabola? Number one, I'd like us to know the vertex. I would like us to know the coordinates for the focus, and I would like us to know the line equation for the directrix. And I say a line equation because this is not the 0.14 or negative 1/4. This is the horizontal line y equals negative 1/4, because horizontal lines are y equals, vertical lines are x equals. So that's what we're going to be finding, these three things, for the following problems. For the first one, I have y equals 2 times the quantity x minus 1 squared. So this, again, is not in the form I want it to be. I need this x minus 1 squared to be on its own. So what I'm going to do is I'm going to divide both sides by 2. Now I have y over 2 equals x minus 1 squared. And now at least I know the vertex. My vertex is going to be h is 1, because it's x minus 1, and k is 0 because there's nothing next to the y in terms of a plus or minus. So the vertex is at 1, 0. Fantastic. Now I need to find the directrix and the focus. To do that, I need my p-value, because the p-value will help me find the directrix. So to find p, I'm going to set whatever's in front of my y equal to 4p. You'll notice there's nothing in front of the y, but there is. It's the 2 in the denominator. Really, it's 1/2 y. In other words, what I'm saying is this 1/2 you set equal to 4p, and then you just solve for p. That's how we find p. Maybe it was confusing in the earlier explanation. Maybe it makes more sense now. I hope it does. But 1/2 divided by 4 is 1/8. Hopefully you know how to divide complex fractions. If you cannot, the internet exists. I'm sure it can help you with that. So p equals 1/8. That means that's the directrix. However, this parabola opens up. So it opens up. That means that my directrix is going to be below. So coordinate point 1, 0 for the vertex. That's about here. Okay. My directrix goes in the opposite direction, and it's down 1/8. Down 1/8 from the vertex, which was 0. What I'm saying is this line right here is y equals negative 1/8. That is my directrix. And again, it's a line. It's a line. Now the last thing I need to do is find the point of my focus, and that's just the p-value in the other direction, positive. So the focus is going to be at the coordinate point, not a line, it's a coordinate point, 1, 1/8. The x value is 1 because it's in line with the vertex, and the y value is 1/8 because it was 0 plus 1/8. Y 0 because the vertex was at 0 for the y. Okay, there's my focus. I've got my directrix. I've got my vertex. And it opens up. That's everything I wanted for this parabola. Isn't that so cool? Okay, now for the next one. I'm going to try and make it hard for you. I've got negative y squared minus 3 equals 6x. So what should we be focusing on whenever we have a parabola problem? Your goal is to get the x squared or y squared thing by itself as quickly as possible. That means adding 3 to both sides. So now negative y squared equals 6x plus 3. And now I don't want to divide the negative over. I mean, I can, but I don't want to, because that negative sign is super helpful to me. It's telling me that the parabola is going to open left. And why left? Because y squared this time. When you have y squared, it's going to open left or right. And if you have a negative, that means it opens left. So that's very cool that I've got all this. Now for the x thing. I'm not happy with x because I need it to be like something in parentheses. What am I saying? I'm saying factor out the 6, and what do you have on the right side? If you factor out a 6, you're left with x plus 3/6, which is 1/2. And the left side is still negative y squared. So now we know the vertex. The vertex is going to be the point negative 1/2, because h is negative 1/2. And k, my y value, is still 0. So there's my vertex. I know it opens to the left. And this 6 is going to help me find the p-value. So I'm saying 6 equals 4p. Divide by 4 to solve for p. P is going to equal 3/2. And that is for the directrix and the focus. So now let's actually draw this parabola. We said it opens left with a vertex at negative 1/2, 0. So if this is negative 1, then negative 1/2 is about there. And it's going to go that way for my parabola. And since the directrix 3/2 is in the opposite direction, so to the right, I'm going to take my vertex, which was negative 1/2, at least for the x value, and add 3/2. That's going to give me the directrix. Negative 1/2 plus 3/2 is just 2/2, which is 1. There is my directrix at 1. As you can see, it has to be a vertical line because this was opening to the left. And so my directrix is going to be the equation x equals 1. Again, that's my directrix. And now if I want to find the focus in the opposite direction, then I just need to subtract 3/2. So it's negative 1/2 minus 3/2. It's going to be negative 4/2, which is negative 2. So negative 2 about here is going to be my focus. Fantastic. Oh, and the y coordinate's 0. So the coordinate point's really negative 2, 0. And there we go. There's my directrix. There's my focus. I found the vertex already, negative 1/2, 0, and the parabola opens left. And now let's just do one more to really see if you understand it. I have 8x plus 4 equals 4 times the quantity, y plus 1 squared. Again, what's the first step? It's getting that y, the squared term really, by itself as quickly as possible. That means I'm dividing everything by 4, and that means I have 2x plus 1 equals quantity y plus 1 squared. At this point, I can say that this is going to be a parabola that opens to the right, and the reason why it opens right is because it's a y squared this time, and it's positive, so it opens to the right. Now for the x part and finding p. Remember, that needs to be an x with no coefficient in front of it. In other words, I'm factoring out a 2. When I factor out the 2, I'm left with x plus 1/2 equals quantity y plus 1 squared. And now I know where my vertex is. The vertex is going to be at h comma k, which is negative 1/2 for h and negative 1 for k. So there's my vertex. Now if I want to find p to help me find the directrix and the focus, then 2, this number right here, I set equal to 4p. Divide both sides by 4. P equals 1/2. And so now I start graphing this. The vertex this time is at negative 1/2 comma negative 1, which is about negative 1/2, negative 1. About here, we said it opens to the right, so something like this. And the directrix is 1/2 to the left of that. So in other words, negative 1/2 minus 1/2 for the directrix, because the directrix needs to be over here somewhere. That's going to be negative 1. So the directrix is at x equals negative 1 for the directrix. And by the way, you can find the focus first if you want. It doesn't matter. But the focus is going to be the x-coordinate negative 1/2 plus the p-value 1/2. That gets me to 0. So the focus is at 0, negative 1. That point right there. The focus is at 0, comma, negative 1. That's the focus. And there we go. That's everything we need to know about parabolas. More than you ever wanted to know, I'm sure. And actually, that's going to wrap it up for all 4 of our conic sections. So if you have any more questions on the other 3, go ahead and find the corresponding video on my YouTube channel. Thank you all for watching, and I hope you have a great rest of your day. Take care, and bye-bye.